We're going to graph the function y equals sine x. And in order to do that, we're going to have to realize that the sine function is periodic. And what that means is that as we graph the function over the real numbers, we're going to find that it has a cyclical repetition. Let's start by just plotting some values here for the sine function. Let's start at minus 2 pi, and we'll kind of go around here. Let's go to minus 7 pi over 4, minus 3 pi over 2, minus 5 pi over 4, minus pi, minus 3 pi over 4, minus pi over 2, minus pi over 4, and then 0. And then we'll continue that. Then at pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Now if we look at what happens to the sine function as we go around the circle here, at minus 2 pi we go around in the clockwise direction one full turn. And we'd be right back here where we have no y coordinate at all. No y value rather. The coordinates of that dot are 1, 0. So the sine is 0. At minus 7 pi over 4 we'd go around and we'd be here where the sine is the square root of 2 over 2. At minus 3 pi over 2 we'd come around here and we'd be at a place where we have the coordinates of this dot on the unit circle would be 0, 1. So the sine is 1. And then continuing with this, we'd have the square root of 2 over 2, 0, minus the square root of 2 over 2, minus 1, minus the square root of 2 over 2, 0. Then at pi over 4, we would have square root of 2 over 2. And at pi over 2, we'd have 1. At 3 pi over 2, we'd have the square root of 2 over 2. At pi, we'd have 0. 5 pi over 4 minus the square root of 2 over 2. 3 pi over 2 minus 1. Minus square root of 2 over 2, and 0 again. So we can see a pattern happening here as we go around this circle over and over, whether it's clockwise or counterclockwise. The sine function ranges from minus 1 to 1, and then is actually continuous. It's going to repeat itself every time we go around. So we've got 0, square root of 2 over 2, 1, square root of 2 over 2, 0, minus square root of 2 over 2, minus 1, minus square root of 2 over 2, 0, square root of 2 over 2, 1, square root of 2 over 2, 0, minus square root of 2 over 2, minus 1, minus square root of 2 over 2, 0. So you can see that these are matching up. This cycle is matching up. So we can graph this thing by making ourselves a set of x and y axes and starting at minus 2 pi and then going to 2 pi. So we can mark off these spots that we have on here. Halfway between minus 2 pi and 0 we'd have minus pi, and halfway between 0 and 2 pi we'd have pi. Halfway between minus 2 pi and minus pi we'd have minus 3 pi over 2, and here we'd have minus pi over 2. Here we'd have pi over 2, Here we'd have 3 pi over 2. But we've gone to pi over 4 units here, so we'd have those spots in between these. And we've noted that the sine function values go from -1 to 1. At minus 2 pi, y is 0. At minus 7 pi over 4, y is the square root of 2 over 2. At minus 3 pi over 2, y is 1. And then we can keep graphing these dots. And what we're finding then, if we just graph 2 cycles of this thing, we have a shape that repeats itself twice. So typically, if you want to graph one cycle of the sine function, you graph it from 0 to 2 pi. And so then we normally recognize the sine function as having this shape here, the graph of y equals sine x.